this video, we're going to talk about building edge data applications through a low-code virtualization approach. So in the past year or so, what we have noticed is that the majority of mid-size and large-size companies we speak to are providing an internal edge orchestration platform. What an edge orchestration platform is a platform that allows users to build data applications, then deploy them through containers to the edge in very large numbers. And typically, the edge orchestration platform is based on a framework like the Microsoft Azure IoT Hub or the AWS Greengrass. And there are providers of edge orchestration platform as well, such as Balena or Partainer, so you can just use them out of the box. What users have to realize is that edge orchestration is only the first step of providing edge data applications. Because in order to build edge data applications, you still have to build them, in code, debug and test, and then package them into a container, push them into the cloud portion of your platform, and then deploy it from there. So this process is very time consuming. It requires a lot of software skills. And what a lot of the companies find is that once they have this orchestration platform, it is still very difficult for their internal business units or their customers to produce edge applications, which is where the business values are, right? So then the natural question that companies ask is, how are we able to build edge applications faster? So what we provide is a framework we call low-code data virtualization. And in this framework, you would have a data virtualization layer living on top of the edge orchestration layer. In other words, the base software of the data virtualization layer is deployed through your edge orchestration platform. But after that, what you do is you build data workflows in a separate cloud software, and then you deploy those workflows into your data virtualization layer block. And why do you do that? This is because the majority of the complexity of edge applications is in the data, in particular in the preparation of data, such as getting the data through different data protocols, validating the data, cleaning the data, transforming the data, extracting events from the data. And therefore, by having that low-code data workflow to build your virtualization layer, you can do that a lot faster than the traditional software development techniques. And also because very often you're adding additional data sources or you need to control additional equipment, that data virtualization layer needs to have the flexibility to be able to support that. Therefore, building data workflows is a lot faster than building typical applications in containers. So what we find is that companies are increasingly adding this low-code data capability as a option, in addition to all the other application development frameworks they have. So what are some of the fundamental functions you need to provide in data virtualization? So the first is streaming, because a lot of the industrial data it happens in real time. So you need to be able to stream very high quality data from your data sources to the applications that require them. The second function is on demand. Some of your applications don't need real-time data. What they need is, they need to fetch a batch of data from some number of data sources to process them. So now you need to be able to do that on demand. And again, you need to deliver the high quality data to the applications that need them. The third functionality is event generation. A lot of the industrial data, because they're time series in nature, they are not as easily analyzable as the structured enterprise type of data. So another function is to be able to generate structured events from your raw time series data and deliver that to your applications. And finally, this is something that a lot of users don't think about, but visualization of your data is actually very important. This allows you to catch the problems you have in your data, the frequency of the problems, the root causes of the problems, so that you can continue to improve your data sources. So it is very common, for example, for us to provide visualization for all the data virtualization projects that we work on. So another important thing that I wanted to mention is that increasingly data doesn't just live at the edge, or they don't just live in the cloud. They actually live in both places. So you want a architecture that can allow you to work with data, whether the data is in the edge or the cloud. So this is an example here, right? So let's say at the edge, you have 200 sites, and data comes from your historians. You have to process that data in every site through a virtualization layer. You could also directly fetch data from your sensors and process that data, in thousands of different locations. And a lot of the data already probably are in cloud-based data warehouses right now. And there's a huge amount of data. So you have to be able to process that through a distributed, containerized type of parallel architecture. And then very often you need to combine the data from different locations, different sources to generate additional insights. So this is very complex if you develop them as individual containers. And your individual containers may also not be able to parameterize your virtualization blocks to work with different, chunks of data. So having that ability to virtualize that entire solution in one single workflow, and to be able to parameterize any kind of data functions in those virtualization layers becomes almost a necessity. Therefore, you want a platform that can allow you to extend to this type of edge cloud type of hybrid environment. So here we talk a little bit about building data virtualization layers. So in our case, we use Node-RED, but obviously you're not only limited to Node-RED. But generally what we find is that you want to use something that's visual, modular, hierarchical, so that it gives you both sort of the simple view of your, virtualized functions, but it also allows you to go, to build fairly complex operations, through a hierarchical structure, including embedding fairly complex data models. One of the things we do notice from our customers is that it's not enough just to adopt, a data workflow type of software. There's still a lot of challenges in building data virtualization layers. If you think about where this data virtualization layers run in the edge devices, they're typically in a resource limited edge device with an embedded OS that doesn't have nearly the capability of the large computing power people are used to. And therefore, reliability is actually not that easy to attain. Your teams probably would have to go through, a lot of trial and error to get there. From the scalability perspective, because the amount of data is very large today, right? In particular, your data warehouses, how do you scale your data virtualization layer to support, multiple hundreds of thousands of data tags? Again, that's a challenge. So those are the problems that we solve a lot over and over. So if you have any questions, if you have any thoughts on data virtualization and how to achieve reliability and scalability, please reach out to us. Thank you.